Welcome to chemistry class with Christopher GK. Of course, your chemistry teacher, and in this particular video, we'll be looking at a topic: oxides of sulfur. Oxides of sulfur is the topic for this particular video, and it's expected by the end of the video, you should have been able to learn how to list the oxide of sulfur. You should be able to list the oxides of sulfur. Number two is you should be able to explain the laboratory and industrial preparations of sulfur 4 and sulfur 6 oxides. Number three is that by the end of this particular video, you should learn how to state the physical and chemical properties of sulfur 4 and sulfur 6 oxides. And finally, you should be able to outline the uses of sulfur 4 oxide. So these are the things we want to achieve by the end of this particular video, and we'll be taking them one after the other as we continue and we'll run this particular class. Now, first of all, when you hear about oxide, oxide has to do with oxygen bonding with a particular element. So oxide of sulfur has to do with oxygen and sulfur as a binary compound. Binary compound of any element of any compound is what we mean. Binary or compound of oxygen is what we mean by oxide. So sulfur oxide, oxide of sulfur is oxygen and the sulfur. And there are many oxides of sulfur, but in this particular video, we'll be considering the two most important of them, which are sulfur 4 oxide and sulfur 6 oxide, are the things we're going to want to consider, and they have oxidation number of +4 and +6, respectively. Sulfur 4 oxide, oxidation number of 4, oxidation number of sulfur is 4, and the sulfur 6, the oxidation number of sulfur there is 6. And that is what we want to consider in this particular video. We'll be first of all look at sulfur 4 oxide, and after considering it, we'll look at sulfur 6 oxide. So sulfur 4 oxide is an oxide of sulfur present in volcanic gases and in water of certain sulfur spring. In sulfur 4 oxide, sulfur exhibits oxidation number of 4. That's why we call it sulfur 4 oxide. And it is a major air pollutant in industrial areas. Sulfur 4 oxide is a major air pollutant in some major industrial areas. Okay, how can we now get this thing prepared? Laboratory preparation of sulfur 4 oxide. How is it being prepared in the lab? Now, in the laboratory, sulfur 4 oxide is prepared by heating sodium or potassium trisulfate 4 with the trisulfate acid or hydrochloric acid. Then the trisulfate 4 acid breaks down to yield water and sulfur 4 oxide. This trisulfate 4, it will break to yield water and sulfur 4 oxide. Now that is how it's been done, and this is the sodium trisulfate 4 reacting with, is being reacted with hydrochloric acid. We said heating it. When we heat it with hydrochloric acid, that is the one we are talking about, it will give you this, and the sulfur 4 oxide will be produced. This is our point of consideration, how we produce it in the lab, and it's a gas. It's the gas that will be evolved. Now, how can we do it? What is the procedure in the lab? One of the things we do, or the things we do in the lab, is this: we place some sodium trisulfate 4 crystal, the crystal of it, in a flask, and in a fume cupboard too. It's been prepared inside a fume cupboard because of the nature of the gas. So we pour some concentrated hydrochloric acid through the tester funnel and heat the mixture together gently. Then the dry gas that will be evolved will be allowed to pass through concentrated tetraoxosulfate acid issue because of drying, and after that it will be collected through downward delivery. Tetraoxosulfate acid is used as a drying agent. It's used for drying the gas that will be evolved, which is sulfur 4 oxide. It will be dried through and will be collected through downward delivery in a gas jar. Look at the image. Now, sodium sulfite, which is sodium triazote sulfate 4, is being mixed together with hydrochloric acid through the test tube funnel here, and is being heated. As it's being heated, a gas will be evolved through down here, and it will pass through this place. This is concentrated tetraoxo sulfate 6 acid. It is a drying agent to dry this gas, and it will be collected here through downward delivery here. That is the method in which we prepare it in the lab. All right, industrially, how is it being prepared in the industry? Industry use a cheaper way and in a way in which they can produce it in a massive way, in a larger quantity. So one of the things they do is direct combination by burning this sulfur and air, burning of sulfur and oxygen or air to produce sulfur oxide. Simple. It makes it easier for them. And the next thing is by roasting naturally occurring iron pyrites in air. This is iron pyrite, and when it's being roasted in air, it will produce sulfur oxide. It's a gas. So that is one of the ways in which it's been done. The next one is this, by heating anhydrides with coke, the calcium sulfate. And when it's being heated with coke is carbon, and when it's being heated, it will produce calcium oxide and sulfur oxide. This is our point of, what we want to produce. But this calcium oxide can further be heated with sand in order to produce slag. Slag, this is is an impurity in a molten form, which will be collected out. All right, that is the way in which it's being produced in the industry. The next thing we need to look at is the physical properties of sulfur oxide. What are the physical properties of sulfur oxide? Number one is that it is a colorless gas with pungent smell. It's because of the pungent smell that makes us to prepare it in the fume cupboard in the laboratory. So another thing is that it's a poisonous gas and should be stored in the fume chamber. Number three is that it is denser than air. That is why we collected it that is why it was collected through downward delivery. And the next one is that it is very soluble in water. So it is used in fountain process experiments. These are the physical properties of sulfur oxide, and they have some chemical behaviors. What are the chemical behaviors? Number one is that it's an acidic gas. What does it mean? It can turn damn litmus paper, blue litmus paper red, which acid does when it is tested with it. Number two is that sulfur oxide dissolves in water to give a weak basic acid. So when it dissolves in water, he forms a weak acid. That is why he could be able to turn blue litmus paper red. What acid does. But you know it's damp litmus paper, not just anyhow. Damp is containing water. It will not show acidic behavior. All right, next thing is that it reacts with sodium hydroxide solution to give an acid salt. Or even it can also give normal salt. At the case of this, sodium hydroxide, it forms an acid salt, but when it forms with 2 moles of sodium hydroxide, it will form normal salt and water. Salt and water, the way acid does to produce salt and water neutralization reaction. Next reaction of field chemical reaction is sulfur oxide does not burn or support combustion. We need to note that chemically it does not support combustion. And another chemical reaction we need to know is that as an oxidizing agent, when hydrogen sulfide is bubbled into the test tube containing sulfur oxide in water, there will be a yellow deposit of sulfur. That is it. Look at it. Look at it. Sulfur will be deposited. And the magnesium continues to burn in sulfur oxide to give a yellow spark of sulfur. And the white magnesium oxide, although it does not support combustion, but supports combustion ordinarily. All right. This is it, magnesium with sulfur oxide, and magnesium oxide and sulfur will be produced. Okay, we have, it also reacts as the reducing action of sulfur oxide. He also does that. And when sulfur 4 oxide is dissolved in water, it has high affinity for oxygen. It has high affinity for oxygen, and because of it, it acts as a reducing agent, and itself is oxidized to tetraoxide 6 acid when dissolved in water. All right. Next thing, one thing we need to note about is when sulfur 4 oxide is bubbled into a solution of KMnO4, the purple color of KMnO4 is decolorized, or it changes to colorless. When sulfur 4 oxide is bubbled into KMnO4, KMnO4 is purple in color, it will get it decolorizes. It decolorizes it into colorless. It decolorizes, it changes to colorless. And this is what we do, and it will form this. All right, so that is one of the behavior when he reacts with KMnO4. But when he reacts with dichromate 6, when with acidified potassium heptaoxo dichromate 6, the orange color of this will change to green. It's still the reducing action of sulfur 4 oxide. It changes dichromate 6, potassium heptaoxo dichromate 6 from orange to green, but KMnO4 from purple to colorless. And the above two reactions are tests of sulfur 4 oxide. It helps us to test for sulfur 4 oxide, and it changes their color with yellow deposit of sulfur. So these are the chemical behavior of sulfur 4 oxide we need to note, that the 6 of them. Number 2 of the reducing action is this. It also reduces ion 3 to ion 2. We discussed one of it, the reducing action, where we treated issue of the KMnO4 and dichromate 6, potassium heptaoxo dichromate 6. Number 2 is that he also reduces ion 3 to ion 2, and it changes the yellow-brown color. It changes the yellow-brown color to pale green. So the reaction from ion 3 to ion 2, from yellow-brown to pale green, that is the reducing action also. Another thing is the halogen can also be reduced to their halide ions by sulfur 4 oxide. He also does such reducing agent, and because of it, it decolorizes also chlorine water, bromine water, and iodine water. So because of this, when it will reduce this chlorine to hydrogen chloride, the halide of that chlorine, hydrogen chloride, and the acid will also be formed, the tetraoxide of 6 acid. All right, that is it. The next reaction of it, which is the chemical reaction, is that sulfur 4 oxide also acts as a bleaching. He bleaches color substances when they are exposed to it. That means he has a bleaching effect. He bleaches color substance when they are exposed to sulfur 4 oxide. It's bleaching action. So, example of substances to be bleached are wood, straw, wood pulp, colored flowers, etc. The bleaching action is due to reduction by triazosulfate sulfate 4 acid, TOS, as we have here. So it has the bleaching action. It has the bleaching action. Next thing is that sulfur 4 oxide is also acts as a pollutant. It has a pollutant effect. Of course, I said it before that in some of the industries is a major pollutant, air pollutant, in industrial areas. Now, because of it is associated with acidic rain substances like fuel, such as coal, oil, and gas, born to liberate sulfur 4 oxide as an acid gas. And its presence in atmosphere dissolves in water to give acid solution. If the rainwater is very acidic, it can cause ecological damage on the surface, and the acid rain attacks metal and limestone and causes them to corrode, that corrosion. And it can be also attributed to decay of ancient monumental buildings. So as an is as one of the pollutants, air pollutants. We observe that in an industrial areas, it's when it's been found in the atmosphere and it dissolves in water, it gives acid solution, and it affects and damages some ecological things around us, and attacks metal, limestone, and even made some metals to corrode. All right, that is it. And monumental buildings, even it will also decay them. You do hear about acid rain. So this one also contributes to that. Okay. So far we have talked about the sulfur 4 oxide. Let's look at the uses of it. And before we go to sulfur 6 oxide. Now it is used as a bleaching agent. Of course, we talked about it through our chemical reaction, chemical behavior of sulfur 4 oxide. So it's being used as a bleaching agent for some substances like wood, silk, and straw, sponge, and several of them. And it's being used in manufacturing of SO3, triazosulfate, which is used in preparation of sulfur 4 tetraoxosulfate 6 acid. It is used as a fumigant to destroy woods and bacteria. This property is utilized for the preservation of food like dried fruits. So we also use in preservation of fruits, and is being used in manufacturing of H2SO4 when it's being used to manufacture sulfur 6 oxide. Through that, is being used to prepare SO4, tetraoxosulfate 6 acid, H2SO4, and as a bleaching agent. Now let's look at sulfur 6 oxide. Sulfur 6 oxide, of course, is also an oxide of sulfur, and it's a Zabit deoxidation number of 6. Sulfur is a Zabit deoxidation number of 6. That's why we call it sulfur 6 oxide. And at room temperature, it exists as white hygroscopic crystal and normal room temperature. All right, and the next thing we need to understand is how is it being prepared? How is it being prepared? We have talked about how sulfur 4 oxide is being prepared. And this sulfur 6 oxide is prepared by passing dry SO2, which is sulfur 4 oxide, and oxygen gas separately over platinized asbestos or vanadium 5 oxide as catalyst at a temperature of about 400 degrees Celsius to 450 degrees Celsius. This sulfur 4 oxide reacts with oxygen to form sulfur 6 oxide, which is used as dense, which is seen as dense white fume. It is solidifies when collected in a flask surrounded by freezing mixture of ice and salt. Simple, we are trying to say is the reaction of sulfur 4 oxide with oxygen gives us sulfur 6 oxide. That is the simple thing. And it forms that by producing something like white fume. And that white fume will solidify. And when he solidifies, it produces sulfur 6 oxide. Look at it. Now, reaction of sulfur 4 oxide with oxygen in the presence of vanadium 5 produces sulfur 6 oxide and the temperature of this. Now, what are the conditions that is favorable for this kind of production, that favor the production of sulfur 6 oxide? Number one is that since the reaction is low, catalyst is used. That's why we use vanadium 5 oxide as a catalyst. Now, number two is that because of the reaction is exothermic, the temperature of the system must be controlled at 450 degrees or between 400 to 450 degrees Celsius. Number three condition is that increase in concentration of sulfur 4 oxide and oxygen and removal of, it will result to removal of sulfur 6 oxide as soon as it is formed. So concentration of sulfur 4 oxide and oxygen enables the sulfur 6 oxide to produce as fast as possible, and it will be removed as it's being formed. Now, its increase in pressure will favor production of sulfur 6 oxide. Increase in pressure. Since increase in pressure favors the reaction of reaction to area of smaller surface. Since increase in pressure favors the reaction to area of smaller surface. So pressure, increase in pressure will favor production of sulfur 6 oxide. These are the conditions that favor the production of sulfur 6 oxide. Properties. What are the properties of sulfur 6 oxide? One of the things is that it's a gas at room temperature. Number two is it's an acidic oxide. Of course, it reacts isothermically with water to form tetraoxosulfur 6 acid. With that, we just know that when it reacts with water, when sulfur 6 oxide reacts with water, it produces H2SO4, which is tetraoxosulfur 6 acid. Number three is that it dissolves in concentrated H2SO4 to form olum, which is Dix. All right. Next thing is that it has no boiling point and readily vaporizes on Gen2 heating. It has low boiling point. It has low boiling point and vaporizes on Gen2 heating. Okay, for now, I want to say that for further discussion and inquiry, get to me through my contact phone number or WhatsApp line, or through my email address. You can send me contact through my email address. We have discussed about oxides of sulfur, two main oxides of sulfur, which is sulfur 4 oxide and sulfur 6 oxide, and how they can be prepared, their chemical and physical behaviors, and even the uses of them. Still remember to watch the next video, which will talk about tetraoxosulfur 6 acid, which is also one of the oxides of even sulfur. Is a product we also get from sulfur because sulfur is there. Thank you for being part of this class and remain blessed.